All right, let's get started. Okay, here we go. Aaron Calhoun, do you think that we will ever find the sun's siblings, the stars born in the same cluster as the sun? Astronomers think that they already have. And the way they did this is sort of two parts, because there's kind of two pieces that you're looking for to try and identify the stars that were born in the same stellar nebula as the sun. The first thing is you're looking for its movement. You're looking for stars that are following roughly the same kind of orbit around the Milky Way that the sun is. And thanks to the Gaia telescope, and thanks to the Gaia mission, astronomers have been able to map out the movements and positions of about 1 billion stars in the Milky Way. And so they found plenty of candidates of stars that are moving in roughly the same way that the sun is. So that's your first issue. Now, there's going to be drift over the course of 4.5 billion years since the sun and its siblings formed, but you're not going to get things that are super weird going in the opposite directions, highly elliptical orbits. You're going to have stars that are kind of moving with the same velocity, same angles, roughly the same kind of orbit. The second thing is the chemical composition. It's assumed that when you have a, stellar nebula, the nebula was enriched with roughly the same kinds of metals. And of course, I'm using metals in the astronomer sense, which is anything that is heavier than helium, anything with more protons than helium. And so you're looking for the stellar fingerprint to be very similar. Same amount of carbon, oxygen. And this is a process that astronomers can determine by looking at the light of a star. It's called spectroscopy. You essentially take the light of the star, you turn it into this big rainbow, and then you're looking for absorption lines or emission lines in that light that line up to the known absorption lines, emission lines of different chemicals when they are ionized. And you can tell what the presence of different kinds of chemicals in the atmosphere of a star just using this technique of spectroscopy. And so there are other surveys that are doing spectroscopy of stars at a vast scale. They are looking at hundreds of thousands, millions of stars, and they are doing this sort of careful, painstaking work of checking the stellar fingerprint of those stars. And so now you cross-reference the two. You are looking for stars that have similar characteristics to the sun, and you're looking for stars that have a similar movement to the sun. And astronomers have found several candidates that they feel fulfill both of those requirements and are good candidates for potential siblings of the sun. And so, we've reported on this in the past in Universe Today. I would say a few candidates have been known over the last about 5 years or so. Did I do the color card? I didn't do the color card, but I think Chaz got the color memorized at this point. Overall opposites. Can we use light bending around a black hole as a time mirror to see the sun in the past? Theoretically, yes. Practically, no. So, the first part, does light bend around a black hole? And the answer is, yeah, theoretically. In fact, when you look at these sort of artist illustrations, these mock-ups of what a black hole looks like, you're seeing light that is wrapping around the black hole from all angles. And so you sort of imagine as you get closer and closer to the black hole, your light is just going to all go in. Like once you cross the event horizon, all light goes in. But just outside the event horizon, there's another region called the photon ring. And this is a region where, theoretically, light can be in orbit around the black hole. But, the way the direction that the photons come in, they're not going to be in these sort of perfect circles. They're going to do loops around the black hole and then go back out in some other direction. And theoretically, there will be photons that have been emitted from the sun. They've gone all the way to a black hole. They happen to hit perfectly at the right angle into an area that's around the photon ring, and they come around the black hole, and then they're emitted in exactly the opposite direction. And so the black hole acts like a mirror for the photons that are coming from the sun. So that's the theoretically part. The practically part is you've got to imagine sort of the numbers here, right? That you've got the sun. It's trying to go to a black hole that could be thousands, tens of thousands, millions of light years away. Like, how far in the past do you want to be able to see the sun? You want to see dinosaurs? You're looking at a black hole that is going to be 65 million years ago. You're looking at a black hole that's going to be 65 million light years away, so that the light is 65 million years ago. And then you got to wait for the return journey of the light. But practically, the number of photons that have gone all the way to this black hole that is that far away is almost none. But then the number that is made a perfect 180-degree turn around the black hole and come back to us is none, right? Like, every now and then it happens, but you've got to be ready for that one photon, and you don't get to really make a sort of a comprehensive view of a dinosaur with one photon. So theoretically, yes. Practically, no. Mark Von Steen. Fraser, if you need to shadow ban people to support your ideas, are they really ideas worth having? So I've never shadow banned anybody. Not ever. I have banned people, but they know they got banned. So I've never done shadow banning. Now, that said, YouTube does do shadow banning. So YouTube has a bunch of policies that are going to prevent people from posting stuff. And, their policies and their algorithms change all the time. One of them is to not put links into your posts. That is the way that spammers attempt to control spaces and market their stuff, is to put links into things. And so YouTube is very strict about putting links into things. Generally, pretty much, I'm the only person who can put links into comments on my channel. Regular posters are not able to do that because YouTube frowns on it. Now, if I'm sort of like, I've got time on my hands and I go into the held section of YouTube and I look through the comments and I see someone who is very helpfully providing a useful reference to some story and it was held by YouTube, then I might approve a bunch of them, but I have to think of it, and YouTube doesn't put it in my face. And I don't know how many posts have been held. So that's sort of that's automatic. Like, if you're going to put links into your posts, just assume that nobody is ever going to see them, right? Or into your comments. But then YouTube has a whole bunch of other stuff that they're looking for. They're looking for language. They're looking for tone. They're looking for things that people might say where they've said the same thing on a lot of other channels, right? Because, again, these are the hallmarks of people who are spamming things, or the hallmarks of people who are trying to kind of degrade the conversation across all of YouTube. And just like by default, you just kind of let all the stuff run because in general, it works pretty well. So, my advice to you is just tone it down, settle down. I'm guessing, based on the hostility of your comment to me, right? Your assumption that I'm shadow banning you, then you've got something to say that you feel like the mainstream media, and me as a member of the mainstream media, as the established space community, doesn't believe in or doesn't approve of. And that's not true. I don't get my checks from NASA. I'm just a journalist. I am definitely err on the side of the scientific consensus. I err on the side of expertise from scientists, but I'm not using my platform to discredit other stuff. I'm using my platform to amplify the kind of news that I think is important for my readers to see. And if you haven't gone through the standard channels of getting your work published in an established journal, getting it peer reviewed by other scientists, I'm probably not going to report on it. And I'm probably, not going to go out of my way to make sure that your voice is heard. So instead of sort of like whatever, I'm not sure what you were saying. I'm not sure, because again, YouTube hides a bunch of this stuff from me. So I don't know. But I'm, based on your attitude, just based on what you said, I'm going to assume that it's the kind of thing that if I looked at it, I'll go, oh yeah, I get why YouTube has been sort of turning the volume down on what you're saying. So instead, just join the community, be open-minded, ask questions about space and astronomy. Just get to know us as opposed to coming in hot. That's my advice to you. Or don't, whatever. I'm not your dad. Draw Ural. Do we know where the habitable zone will migrate to when the sun gets hotter? Will Titan become habitable? So the sun has a limited lifespan. It's going to live for merely another, 5 to 7 billion years. And as it continues to age, it's going to get a little bit hotter. It's going to get hotter in about 1 billion years so that it boils the oceans on the Earth. But it's really going to change its temperature when it reaches the end of its life, when it's used up all of the available hydrogen in its core. It's turned all the hydrogen into helium in its core. It switches to helium burning, and that kind of changes the characteristics of the star. It gets into its sort of end of life, and it will bloat up as a red giant, and it will consume Mercury, Venus, maybe consume the Earth. The science is uncertain, and sometimes people say it's going to eat the Earth. Others say it won't eat the Earth. Who knows? But the habitable zone around the sun will absolutely change. It will extend outward. And one of the things that is going to happen is that Jupiter will go into the habitable zone. So we're going to get the large ice moons around Jupiter will melt. And so you'll get a liquid ocean on the surface of Europa and Ganymede and Callisto. Io will still be just a volcanic hell. But so briefly, for a few 100 million years, those moons will be in the habitable zone, which will be really interesting. Now, it won't be a sort of a great life, and you're going to get these really big fluctuations in temperature output coming from the sun. They often, when they get into this red giant phase, they'll go through these cycles. They'll bloat up, then they'll sort of reach a new equilibrium, and then they'll collapse back down, and then they'll blow it up again. And each time they do this, they will sort of shed this shell of material that goes off into space. So it won't be sort of like a nice, dependable water world that you can live on, but it will definitely change the situation. But I don't think it's going to go all the way out to Saturn. Saturn is much farther away from the sun than Jupiter is. So my understanding is that Jupiter's moons will melt, but not necessarily Saturn's. But it will get warmer, for sure, that far out. Nicholas Cunningham, Fraser, do you mess around with any Dragonlance? Do you strictly read science fiction? I'm a Dungeons and Dragons enjoyer. I actually am the dungeon master for a Dungeons and Dragons game for my kids and their friends. My adult kids, they're in their early 20s, and I am the dungeon master. Playing on this sort of campaign that is a mix of Mass Effect and a more traditional and Cthulhu, where essentially there are these eldritch horrors that are looking to consume the planet, and the adventurers are discovering the terrible truth. So I really love that concept of like the Reapers from Mass Effect, and so I've kind of implemented that in a fantasy setting. And anyway, so I'm the dungeon master. But back in my day, like ready for my nerd cred. So I've submitted a Dungeons and Dragons adventure to Dragon Magazine back like when I was 20. It was rejected very nicely. I've written several role-playing games. I did a adventure for Shadowrun. I contributed. I made the monster manual for Earth Dawn, which is a game that's out of print. I contributed to a bunch of other source books. And then I stopped working on role-playing games and switched to computer science and making software companies. So, but I used to organize Dungeons and Dragons or role-playing game tournaments in Vancouver, and have been playing role-playing games as a player or as a dungeon master. I've been playing role-playing games off and on as a player or a dungeon master for almost my entire life. 54 now. I think I started playing role-playing games when I was 10. I think I can remember us playing Dungeons and Dragons in elementary school when I was 10. So I used to work at a comic book store in Vancouver where I ran the Dungeon, which is the role-playing game section and fantasy and science fiction section of the store. And so I ordered all of the stuff that we would get in stock. I would teach people how to play games, taught people how to play Magic the Gathering when it first came out. And so, I am very familiar with the Dragonlance books. I've read like all of them. Well, I read them 30 years ago or 25 years ago when they first came out, as well as a bunch of the original sort of D&D books that had been released at the time, the Drizzt, the Dark Elf series, and by R.A. Salvatore and a bunch of others. So, haven't looked into Dragonlance anytime recently, Forgotten Realms, any of that. I much prefer rolling my own campaigns. It's much more entertaining to me to sort of come up with the ideas of the campaigns whole cloth and run them. So, so I am familiar. So no, I'll read science fiction, fantasy, contemporary, anything really. I have a sort of modern, eclectic taste across various concepts. Was that a question on the... Okay. We get it. You're a super nerd. Yeah, super nerd. Hopefully, I'm one of you. Some of you may find that. Some of you are like, I don't understand a word he just said. Bigglestinton. Biggles Tintin. How long will Voyager 2's power last? So the Voyagers were launched in 1977 and have been operating continuously all of this time, right? They're almost at their 50-year mark, but they are powered by an RTG, a radioisotope thermoelectric generator, which is a chunk of decaying plutonium that gives off heat. Then they have a thermocouple that is attached to the RTG that turns that heat into electricity. And because plutonium is a radioactive element, it has a half-life, it is producing less and less of this heat over time, which means that there's less and less electricity that's available to the spacecraft to be able to run its operations. And over time, over the decades, NASA has shut down each one of the instruments on board the spacecraft to make use of the remaining electricity. Now, a lot of the instruments are no longer necessary. You're not going to need to have its camera system because it can't take pictures of anything. Now it's out there in deep space. But the real value now, because they're so far away from the sun, is that they're sort of detecting the presence of interstellar material. They tracked their movement through the outer layers of the atmosphere, through the heliopause, heliosphere, helioshock, heliosheath, and into interstellar space. And they sort of experienced as various solar activity and was decreasing and increasing the size of the heliosphere. And they've been able to give this really interesting information. So there's a few scientific instruments still on board, as well as their communication systems, so that they can still send all of these data back home to NASA. But the power continues to decline. And how long the power is going to last is still an unknown. We are probably in the last 10 years of life for the Voyagers, but exactly when NASA is going to make that call and shut off the last instruments, we still don't know. But they're still sort of extracting every little piece of science that they can from them until they have no other choice. That, there's only enough power to either operate a science instrument or send data home. At that point, you might as well turn the thing off and focus those resources on other things. Part of the problem is that NASA is constrained by its ability to communicate with the deep space spacecraft. It has this thing called the Deep Space Network. These are sort of giant radio dishes around the world that it uses to communicate with the different spacecraft around the solar system. And you can go to the Deep Space Network page and you can see which spacecraft NASA is communicating with right now. And all of the dishes are always fully used. And so if, the spacecraft can no longer if the spacecraft can no longer deliver usable science, they will free up slots for the Deep Space Network to communicate with other spacecraft. So, they're not going to leave them around longer than they need to. We're probably in the last 10 years or so. But I think I said that like in a video 10 years ago. So who knows? TZ Vita Backman. Have there been any new updates or discoveries regarding Planet 9, Planet X? Nope, no new discoveries. Really, astronomers have done the best surveys that they can with the tools they have available, and Planet 9 has failed to be found. So we're going to wait for new tools and new capability. And of course, the perfect tool is coming online within the month, and that's going to be the Vera Rubin Observatory. So it's going to be scanning the entire southern sky, which includes the plane of the ecliptic, which is where objects are going to be expected to be. Anything orbiting around the sun is going to be in the plane of the ecliptic, mostly. So Vera Rubin comes online, it'll be scanning the southern sky. That includes the plane of the ecliptic. They're going to probably put more emphasis on the plane of the ecliptic to find some of these objects. And so if it's there, that'll be the tool that'll find it. And if it doesn't find it, then that puts some serious constraints on the theory. Already losing my voice. Okay. That is the downside of doing a show early in the morning. My brain is good, but my voice is not warmed up. Mungo Halfbrain, are we 100% sure that the universe is expanding at exactly the same rate in all directions? We are not 100% sure, but we are pretty sure. And the main assumption that astronomers use is that you are not special, that the place where we exist here in the universe is normal. Now, by normal, of course, we have this really interesting planet Earth, and we have this cool solar system, and we have the Milky Way galaxy and all of that. But at sort of like the largest scales, if you unfocus your eyes and kind of look at the universe, you're going to see roughly the same stuff. That you're going to see galaxies, you're going to see galaxy clusters, you're going to see stars, planets, dark matter, dark energy. And they're going to be in roughly the same kinds of sort of compositions. And once you make that we're not special sort of assumption, then you can make a lot of progress, right? You can say, well, if we count the number of stars that are in the Milky Way galaxy, and then we know how big the Milky Way is, and then we look at another galaxy that we can't count the stars in it, we can estimate the number of stars that are in that galaxy. We can estimate the supernova rate based on the observations that we've done closer to home. And one of these assumptions is that, the expansion of the universe is continuing in all directions at roughly the same rate. And that matches the observations. Like, astronomers have done a lot of calculations and observations that reinforce this idea. For example, if you, again, squint your eyes and you sort of randomly pick up chunks of the universe, like large chunks of the universe, and compare them to each other, the variations between those chunks are actually really small, like 1 part in tens of thousands. At the largest scale. A cubic billion light years of material from one part of the universe is kind of exactly the same as one other part of the universe. And so whatever forces are driving the expansion of the universe, the leftover momentum from the Big Bang, the accelerating impact of dark energy, the slowing down of the universe from gravity, from dark matter, and so on, they're roughly the same. And so it's assumed that what we see in all directions is roughly the same. Giga Sigma. Thoughts on putting a reflector in orbit to eliminate darkness at night? So I've done an interview with scientists behind that idea, and we talked about it in the episode. So it was about a year and a half ago, I think. And the idea was that you could have a reflector that would give a little bit more sunlight to northern regions, places where light in the wintertime is at a premium. And, cities, things like that to the north. And it is theoretically possible. It's going to be incremental. In other words, that, you would have to make a gigantic reflector that would be very expensive to launch. And the benefits that you get is like a little bit more light outside during twilight, during night. And there, they were making the argument that there's a few sort of niche reasons why you would do this, but that does not create an overwhelming financial incentive to do a thing like that. And there are plenty of potential downsides. That animals are confused by light being there in the wrong places. Think about how moths are always sort of going after your lights. Our own sort of day-night cycles get messed up. There are potential consequences, and then you're essentially adding to the net energy budget of the planet Earth at a time when we're already concerned about adding to the net energy budget of planet Earth, right? Light rays that should have missed the Earth are being redirected to hit the Earth. And so you're pumping more energy into planet Earth. Not very much, but it's not zero. So, until somebody makes like a really compelling reason why you're going to want to redirect this light to the Earth, I think most people, most scientists, most policymakers are going to go, nah, right? I think people dramatically underestimate how expensive it is to put things into space. That, there's all this talk right now of putting data centers in space. And, people think, like, wouldn't it be cool if we put data centers on the moon, right? And if you could teleport data centers to the moon or teleport data centers into space, then there would be like a bunch of challenges. Like you can't fix them, you can't repair them. You have to have solar panels that are pulling in energy. You've got to have appropriate amounts of waste heat that is being radiated back out into space. The farther away you have it from the Earth, the slower the transmission times. You're going to have to sort of do heavy processing on these things, but not be able to transmit a lot of data to and from your data satellites. But that's if you teleport them, right? Like it would be like a marginal business case if you teleported them. But you don't teleport them. You have to put them on a giant rocket, and you have to spend tens of millions, if not hundreds of millions of dollars to put these things into space. $1 billion to put these things on the moon. Suddenly your cost incentives go out of whack. And so always you have to consider, does it make sense to do this kind of stuff when you take into account the full process, as opposed to just, turn on a light outside, as opposed to dig a hole in the ground and grab some gold, as opposed to set out a bunch of solar panels to harvest electricity. So it will always be competing with just doing stuff down here on Earth. Han Solo, will there be space news about a new ESA budget? So that's interesting. So I've reached, so there's a new new ESA, European Space Agency, program called Cosmic Horizons 2040. And this is their version of the decadal survey, where they're starting to put together their priorities for the future. And so I've reached out to the program director for Horizons 2040, and I'm going to look to do an interview. They just got back to me and told me they're busy until the new year. So hopefully I'll just keep pushing until I can get somebody there to talk about it, because, I'm seeing a flood of papers in archive, all sort of connected to this idea, different future instruments and sort of what, new telescope ideas, new mission ideas, like it's my bread and butter, right? And so I want to sort of start at the top, understand the goal, the objectives, so on. And then I'm going to start cherry picking different cool ideas for missions and talk to people. So it'll be sort of like NIAC, right? Cool out there ideas, sci-fi ideas that ESA is considering to push the next generation of science. So stay tuned for all that. ML Brilliance, when do you think we will be able to see the great attractor unobstructed, and what do you suppose we'll hope to find? So we have already seen the great attractor mostly unobstructed at this point. And, it is always incredibly fascinating to me that this is still seen as some kind of gigantic mystery. And it sort of shows how there's this lag between sort of old media, old mysteries, and modern astronomy techniques and the new tools. And so, you might have Carl Sagan in 1981 talking about quasars on Cosmos, and we're like, quasars, what are they? Some people think that they're communications from alien civilizations, and other people think that they're supermassive black holes. They're black holes, and other people think blah, blah, blah. We know what quasars are. We know what they are. We know them very well at this point. And so the great attractor, again, like maybe in the 1950s, this was a big question, but now we know what the great attractor is. Most of it has been mapped. We understand it very well. And that it is, surprise, surprise, galaxies on the far side of the Milky Way. That they are obscured by the gas and dust that's at the center of the Milky Way. That is, when you look at the Milky Way in a visible light telescope, you get the dust lanes that go through the center of the galaxy. This is called the zone of avoidance. And I always joke about this, right? It's not the zone of avoidance because you're going to be in trouble if you point your telescope towards that area. It's like, don't bother. There's nothing there. You're not going to be able to see through the dust. You're just going to see dust. So the zone of don't bother. But we know that other wavelengths pass through that gas and dust, especially infrared. And so what do you know? We have a bunch of really powerful infrared observatories that are able to observe through this gas and dust and reveal the galaxies that are on the other side. And there's been some papers that we've reported on fairly recently talking about how astronomers are continuing to observe more and more of the galaxies that are on the other side of the Milky Way, building up sort of not just how much mass is there that's sort of contributing to the pull of gravity that is sort of sliding galaxies towards the great attractor, including the Milky Way, but the actual positions of the different galaxies that are over there on the far side. So, this is sort of one of those mysteries that has a huge lag from what is sort of in the popular zeitgeist about this mystery and what astronomers actually know about it, right? When you think about the Nobel Prize that was given to Andrea Ghez and other researchers for their work on black holes, infrared telescopes looked right through the gas and dust, and they're looking right at the center of the Milky Way, and they're watching stars that are orbiting around the black hole at the center of the Milky Way. This has been done for 20 years. So we have the techniques, and the knowledge is there, and the mystery is very mundane. Esma RL, why do we call Venus and Mars Goldilocks zone planets when they're not inhabitable? Doesn't this mean that we're looking in the wrong zone around other stars for Earth-like inhabitable planets? So the habitable zone, really the only rule for the habitable zone is that in that region, liquid water can exist on the surface of an exoplanet. Full stop. That's it. So you do the math and you say, with the thickest possible atmosphere, with the right conditions, can you get liquid water to form on this planet? If it's too close to the star, then no amount of good atmosphere, perfect conditions is going to make water be able to form. It's going to boil away. It's just going to be too hot. And then on the flip side, you say, is there no amount of perfect atmosphere that could get us to this place where you could have liquid water on the surface of this planet? It's just going to freeze. And so in between that zone is the habitable zone. There is theoretically water on the surface of those worlds. Now, practically, as we see here in the solar system, it isn't always the case. That you look at Venus, Venus is this sort of runaway greenhouse effect. It's too hot. It has a thick atmosphere of carbon dioxide. But you could tweak the atmosphere of Venus in ways that would get it to be a planet that is habitable, that is not too hot, that there's liquid water on its surface. It might be, steamy, but it's going to run at a higher average temperature than the Earth does, but it is theoretically possible. And then the same thing with Mars. We know that Mars had water on its surface in the past. It doesn't have it today. The atmosphere is too thin. But if you came along and you thicken the atmosphere and put in the right constituents of it, you could tweak the planet to get to a place where there is liquid water on the surface of Mars. It could be as habitable as the Earth. We're not quite as habitable because it gets less energy from the sun and it lacks a planet-wide magnetosphere, but it could have a planet-wide magnetosphere, if it was like a little bit larger. My point is that really the habitable zone is really this very blunt hammer to just come with this first pass, right? And then the second pass, theoretically, when we have the tools, when we have the chops, is for us to examine the actual planets in that zone to find out if they specifically do or do not have the various indicators that we're going to be looking at for potential for life, that it does have water on its surface. Like, how do you know if a planet has water on its surface? That is a really complicated and very tricky observation to make. It is beyond the capability, probably, of our current generation of telescopes. But what we can do is examine the atmospheres of planets that are in those zones. Actually, we can't even do that. We can examine the atmospheres of planets that are in the habitable zone around red dwarf stars, maybe. That's where we are right now, technologically speaking. And then the next generation of telescopes will hopefully allow us to be able to examine the atmospheres around planets orbiting not only red dwarf stars, but maybe around stars like our sun. And then people have come up with other ideas about how you might be able to detect the presence of a liquid ocean on the surface of a world, either through the chemistry in the atmosphere and the interactions between the water and the atmosphere, or maybe you're looking at the reflectivity of the planet, or maybe you're looking at a moon and the planet and how the light is bouncing off the planet, off the moon, and you're able to observe it. Like, it's all going to be very difficult. But you need somewhere to start. And so the habitable zone is just this, like, it's possible in that zone. Now, is it there? That's future science to try and figure out. Nolan Bartels. We've seen a lot of astronauts and cosmonauts sharing space on the ISS and on trips to and from it. Do you envision any taikonaut astronaut missions in the future or astronauts on Tiangong? Probably not. But of course, like, what's your definition of an astronaut, right? Is an astronaut an American trained spacefarer? Or is astronaut the general term for a person who goes to space? So, the Russians call them cosmonauts. The Chinese call them taikonauts, taikong not. So what's, how's this going to work out? So American companies and government groups are expressly prohibited from interacting with Chinese aerospace firms. It's a law. ITAR? Anyway, it's a law. And they're not allowed to interact with them kind of in any way. You can't sell aerospace stuff to China. You can't sort of interact at a policy level. They are separate magisteria. And so the Chinese have found other partners for who to build their space station with. They announced that the first international astronaut is going to be joining them, someone from Pakistan, and they've got conversations with a lot of other nations. So I can imagine there would be overlap. Maybe a Japanese astronaut will go to the Chinese space station, or a Korean astronaut, or maybe someone from Canada. But it all sort of depends on how the US is going to enforce its policies with its partners, right? Like, if you station an astronaut on board the Chinese space station, are you sort of violating your policies with the US? Like, this is all unknown right now, and we don't know. And the problem, of course, is that the International Space Station is sort of at the end of its life. Within about 5 years or so, they're going to deorbit the International Space Station. The US has no plans to build a new station, has mostly canceled its plans to build the Deep Space Gateway, which was going to be the follow-on mission to the International Space Station. And so the United States will have no space station. And, they'll have potentially private space stations, but I am always incredibly skeptical about anybody who announces that they're going to be building a private space station. Building a space station is very expensive. The revenue for that space station is unknown. The business model is unproven. And the thing that space startups do is they go out of business. And so, although we do report on it, things like VAST, like, there's some great ideas, but it's one thing to have a great idea. It's a completely other thing to actually make this thing built, operational, launch into space, hosting people. I think, that would be NASA's ideal, is that there is a private space station that, just as with Crew Dragon, just as with the lunar version of the commercial services, that they can book flights to this private space station, run experiments on board the station, pay for that, but not have to manage and maintain the actual station. That would be their dream. But if that doesn't come together, then the US will have no place to go to send humans to space, apart from whatever happens with their upcoming lunar plans. Now, we're still just like a week after confirmation that Jared Isaacman is going to become the NASA administrator. We're kind of waiting for him to roll out his plans, but his plans are going to be sort of set within the preferences and the goals of the White House administration, as well as what Congress wants, what Senate wants. So we don't really, like, right now, it is almost like it's a clean slate. We don't know what's going to happen. And the problem is that space exploration is one of those things that you don't just randomly, one does not simply arrive at the moon. You have to have long-term plans. And if your plans are going to get reset after every administration, you're going to end up going nowhere. And right now, we've got Artemis 2, it's going to send humans around the moon. We've got Artemis 3, but we don't sort of know if and when and how that's going to happen and what's the configuration. And there are loose plans beyond that, but they depend on the Deep Space Gateway. The Deep Space Gateway is probably going to get canceled. So we really kind of don't know. So all the way back around, I would say within 5 years, the Chinese space station is going to be the only game in town. And they are going to host the country's astronauts, spacefarers, with which they have their legal right to be able to do that. And if the US wants to be able to send astronauts to the space station, they're going to have to renegotiate both their internal laws as well as their international partnerships to permit that. And it would be amazing, because I think that having international collaborations is one of the best ways that you can promote peace. But I don't think it's likely. But we'll find out. Everything compute. Any idea why James Webb has not observed the spectra of planets like Kepler-22b, which is an ocean world? So we don't know if Kepler-22b is an ocean world. There was a science study that came out that looked at the chemicals in the atmosphere of Kepler-22b and proposed that it might be an ocean world. But other people have suggested that there are plenty of other chemistries that could explain the signals, because you're not seeing the water glinting off the surface of Kepler-22b. You are seeing spectra of various chemicals that are present in the atmosphere of the world. You're seeing methane, you're seeing carbon dioxide, and some other chemicals. I think a hint of sulfur dioxide, but people argue about whether or not that's present. And sort of this is following this proposal of this idea of Haitian world, that you can have planets which would be considered not in the habitable zone, but if they have a thick hydrogen atmosphere envelope and they have a very deep ocean of water, it could be liquid water on the surface of the planet, and it sort of violates the habitable zone and actually allows for things to be inside or outside of the habitable zone. There's even been ideas that these Haitian worlds, if they exist, could even be habitable around, say, a rogue planet, just purely through the tidal interactions of the planet. So that's one theory, but it is not a theory that is held by all of the exoplanetary community. There are plenty of others who are skeptical about this idea of Haitian worlds at all, that if you have a planet that has a lot of water on it, it has a mantle. The mantle and the water are going to interact with each other. The water is going to be drawn into the mantle of the planet to a certain degree, and you're not going to get this thick ocean. The hydrogen is very reactive. You're not going to necessarily get this planet forming in this way. Another perfectly reasonable way to explain what you're seeing is a magma world. That if you have a planet that is covered in magma and the magma is putting out various volcanic gases into the atmosphere, that the chemical signature, the resolution that we've got from James Webb explains the data, and many argue better. And so we're in this world where the tools are not good enough to know whether that planet is covered by a thick ocean of liquid water or a thick, molten surface pumping out volcanic gases. One sounds more habitable than the other, and we don't know which one it is. So, we have gotten plenty of spectra on certain planets and learned a lot. Mostly the planets that are being observed that we've been able to get the spectra are already uninhabitable. right? You're looking at giant planets. You're looking at things where you're detecting the presence of uh, um, iron in the atmosphere, right? It's like it's so hot. Really the dream is to find planets that are in the habitable zone around these red dwarf stars. And this has been a really elusive measurement that people have been trying to make. There's this idea of stellar contamination, that the star is having slight variations. And of course, when you're trying to measure the changes in brightness and the chemical characteristics of a planet as it's passing in front of the star, if the star is up to nonsense, that doesn't help your observations of the planet. And so we're in this time where astronomers are recalibrating and developing new data methodologies to try to be able to tease out what is planet and what is star. And we're not there yet. We're probably, it's probably going to be, or at least we're not there yet with the short amounts of time that James Webb has been able to assign to these different kinds of observations. It's going to take longer. And, because time on James Webb is so precious, nobody has been able to get enough time. I think the observations of the TRAPPIST-1e, I think they had 3 transits that they were able to observe. I forget the exact number, but a paper came out that said, okay, we probably need 15 to be able to really get to pin down whether or not there's an atmosphere on this world that is relatively close, orbiting within the habitable zone of a red dwarf star. This is the kind of planet that if we can find an atmosphere around it, if we can detect the presence of water, vapor in the atmosphere, that tells us that maybe there is an ocean there. But so far, none of those observations have been successful yet. Right? Like we're at this time when nobody has detected the presence of an Earth-sized world orbiting around a red dwarf star with an atmosphere within the habitable zone. Not to mention Earth-like world, sun-like star. So it's still early days for this whole process. Question. Frosty Winnipeg just started watching For All Mankind, and the Guam launches of a Saturn V rockets from the water seems implausible. Thoughts? So that is the Sea Dragon. And that's an idea that's been around since the 60s, I think. So do a search on YouTube for Sea Dragon, SEA. And then you will find plenty of videos that are going to go and tell you all about the Sea Dragon for hours and hours and hours, because it's a really cool idea. And it was amazing. If you watch For All Mankind, the last scene in the first season is a Sea Dragon launching. And it's sort of this idea that people have been nerding out about. There's a whole, group here on YouTube that is super excited about the idea of the Sea Dragon. And they actually showed it off for the first time, which was pretty cool. Is it plausible, implausible? It's an idea from the 60s, maybe 70s. There are newer ideas like fully reusable 2-stage rockets, which are probably more feasible, probably more efficient, but who knows? Maybe a fully reusable 2-stage Sea Dragon. That'd be a thing. Adia Ferre. Fraser, how do you feel about getting the same questions over and over again? What questions do you hope someone will ask? I don't mind getting the same questions over and over again. I enjoy it because it allows me to sort of practice giving my answers. I think we get good at saying things when being eloquent. It appears that we're eloquent at the drop of a hat, but really it's just practice. I've done hundreds of these live streams, not thousands yet, right? Hundreds. Yeah, hundreds. And it has really made me a much better science communicator. I'll get an email from a television station or from a podcaster, and they want to interview me. And I'm like, sure, yeah, whatever, right? Do you want to know our questions? I don't care. Anything. It'll be fine. And then I get me able to do the stuff on the spot, that I have this sort of knowledge that builds up over time. I've got all of these ways that I say things, and I sort of think did that land? Did that work? Did that resonate? Was that good? Can I do better? And over time, I get a chance to practice these ideas. The thing that I worry about is just whether the audience is bored of this stuff, right? That, all of us come into our understanding of space and space exploration and astronomy and all this kind of stuff with very little knowledge and a lot of sort of science fiction nonsense that's been jammed into our heads. And then we build up our understanding and our knowledge over time, that we're then looking for more and more advanced information, right? You're going to watch one video about the sea dragon. You're not going to watch 10 videos about the sea dragon unless you're really a sea dragon enthusiast. And the amount of additional information that you're picking out of that video is getting less and less and less, until eventually it's all just, comfort food. It's rehashing. You're not learning anything new. And these question shows are by their nature sort of on that spectrum, where people who are probably newer to the field, very enthusiastic, they're sort of discovering this love of space and astronomy, and they have a bunch of questions, and they're the natural questions that we all have as we encounter the stuff. If you go back to listen to Astronomy Cast, which is the podcast that I do with Dr. Pamela Gay, we've got over 750 episodes, 18 years, you listen at the beginning, and I'm asking your questions to Pamela, right? And now here I am 18 years later. I've been doing this job day in, day out, day after day, year after year. I have sort of honed myself into a science explaining machine. All of this stuff, pretty much every single question you're asking me is some flavor. Unless it's the really new stuff, I've answered this question in some cases several times, in other cases dozens of times, and it doesn't bother me at all. I am never bored by answering questions about space and astronomy. I enjoy it every single time, which is I don't know what's wrong with me. That sounds weird, and yet that's like that circuit in my brain that goes, I'm so sick of this question. Just literally does not exist. So don't worry about me. But I worry about you. I worry about the people who are watching this, and they're like, oh man, right? That, you're going to listen to the question show for the first time, and you're going to be like, oh, this is really cool. And oh yeah, I was wondering about that. And then, okay, now I finally explained this, this thing, right? I thought the great attractor was a mystery, but now I understand that it's not so much of a mystery, so on and so forth, right? And then over time, the percentage of the question show that is going to be new and unique and novel to you is going to wear off. And you're going to be like, okay, I like Fraser, and I like the way he presents this stuff, but I kind of know the answers that he's going to give, right? Yep, called it. Yep, called it. Yep, I knew that. Yep. And so the nuggets that you're going to get out of each episode is going to go down and down and down. And that's why, as I'm sort of answering these questions about, about space and astronomy, I'm part of my mind is kind of going okay, have we had too much of this question? Are people going to be bored by this? But my shows are a journey for you. I think that you're going to come at this at a certain point. You're going to be gobbling up as much information as you can, and you'll get to this place where you're kind of graduating. But that's because I want to provide a range of other stuff for you. So, we have Space Bites, which is the news. And so it's going to rely on these concepts that, and I'm not going to take a lot of time to explain gravitational lensing, interferometry, exoplanet detection, habitable zone, great attractor, blah, blah, blah. I'm just going to reference them and move on. And so you're going to want to have that underlying knowledge across the board of what that is. Imagine if there was someone who's explaining news in some sport, and they're like, okay, so like football is this game that's played and like every time. You'd be like, no, just give me the news. I just want to know the news, right? Japan is what's called a country. Like just tell me what happened in Japan. So that's what we do with Space Bites. And so the question shows are there to fill in all the gaps in your knowledge so that you can understand the news and experience it. The advanced stuff that I think will always be relevant are the interviews, right? Because then I am taking my current knowledge and I am asking the kinds of questions to a researcher that I think is going to answer the gaps in my own knowledge. And so it's like, by definition, they're going to be things that are very new. And so hopefully you go like, I don't watch the question shows anymore. Like they're just too basic for me. I like Space Bites. I like to see on top of the news. But the thing that you should be shifting to over time are the interviews. The interviews are where you are watching me interact with the scientists who are doing the work, that are always at the cutting edge. And the choices that I'm making on the people that I want to talk to are the ones that are always going to be giving us the freshest, newest information. And you will now shift over where your knowledge is, a decade ahead of everybody else who you interact with. And then the other thing that I think is interesting, and like this is going to sound like I'm pitching the Patreon, but it's not really. But anyway, which is that we do a version of the question show over on Patreon where I put out a call to the patrons and say, okay, send me in your questions. And then my producer Anton and I will answer them. And it takes about 3 to 4 hours to 5 hours to answer all the questions. We 100% guarantee every single question that gets asked, we will answer it. And those questions are nuanced. Those questions are different. Those questions are complicated. They require research. They require math. Anton has a physics degree, which is great. And so between the two of us, we can get to the bottom of these questions. But sometimes I have to reach out to scientists to get answers from them. It is exciting to me because I am discovering the answers to these questions as I'm attempting to answer them. And so it's sort of like, if you do want a more advanced version of the question show, I highly recommend you check out the patron version. Like obviously you can sign up, $3, download all of the past patron shows, cancel your subscription, away you go. Or become a patron, ask your question month after month after month. It's really fun. No, I haven't played Dark Raiders. Andy Karras, do we have any ideas about when James Webb will do the deep field? No, I've talked to scientists about that. Essentially, they don't have enough time on James Webb yet that it makes sense. But there are various surveys that are being done, and the various people who are running the surveys are talking with each other, and they're starting to kind of scope out what a deep field might look like from James Webb. And so whenever the telescope is not oversubscribed and this feels like it's the right priority, then they'll do that. And it'll be amazing. SD Landshare. Regarding the detection of life signatures on the surface of planets, asteroids, comets, what molecule or pattern discovery might split scientists in two? Sugars, lipids? So this is the challenge of astrobiology, really, is what is a biosignature that would be a convincing evidence that there's life on another world. And as you said, the kinds of raw material for life has been found everywhere, both in comet asteroid samples, as well as like detected in large star forming regions. Like it really looks like before you get a star, the raw materials for life is already present. Amino acids, various hydrocarbons that are used by life, sugars, various gels, gums, all kinds of stuff seems to be present. All the raw materials there and ready to go. Now, we're not entirely sure if there are mechanisms that will deliver that stuff gently to the surface of a planet. You know, if you're delivering a package of amino acids on an asteroid at 20 kilometers per second and you're slamming into a planet, it's not going to hold on to its bonds, right? It's going to turn into a bomb, and then you will have lost all of the amino acids. But so this is still a question. Can you get gentle delivery of this stuff from space down to the surface of the Earth? And I've interviewed people who have sort of explained mechanisms where that might be possible. So it really feels like all of the raw material for life is being delivered to the surface of planets. And then in theory, you know, if there is life and they're going to be it's going to be going out through its various activities, it's going to be producing, you know, it's going to have various molecules that are part of it. It's going to have various chemicals that it's going to be leaving as waste products. And that if we could then get our hands literally on those rocks, those waste products, whatever, then we could potentially detect life. And so there's like two sort of versions of this. The one version is like us just trying to find it here in the solar system. You know, we send a rover to the surface of Mars. It finds the most interesting rocks. It collects samples. A future Mars sample return brings those back to Earth. And then scientists look through the rocks to try and figure out, is there any kind of you know, is there a clue that life is operating? It's not just geology, that actually biology participated either now or in the past. And the problem is that if it's in the past, then the actual amino acids, the sugars, all of that kind of stuff, the lipids, it's all gone. All you have are the chemistry that remains, the sort of snapshot. When you think about, say, a fossil, right? Like a fossil is not a dinosaur bone. A fossil is a dinosaur bone that was replaced by rock. You don't have the bone, you just have a rock in the shape of the bone. And so it's the same kind of thing, which is that you're going to pick up a rock. It's going to have once had life in it 1 billion years ago. You're not going to find the life. You're not going to find dead life. You're going to find the chemical results from life. And then that makes it inconclusive again. And so scientists are going to argue. And I think, you know, we've seen the kinds of arguments that scientists have had already about the presence of methane on Mars, the Allen Hills meteorite, the Viking experiment, that those are the kinds of arguments that scientists are going to have and will continue to have, even if we have what appears to be smoking gun evidence of, you know, that life, there's no way you could have done this except for life. Some scientists can go, well, I can think of a way that this could have been produced without life. And people are like, yeah, you're probably right. Okay, it's not conclusive. We'll keep looking, right? The only conclusive evidence is going to be actual active life. And that means you're going to need probably liquid water. You're probably going to need a source of energy. You're going to need the kinds of chemistry that's going to be available. Maybe there are places on Mars deep underground where you could find that. Maybe you're going to find that on Europa, Enceladus. You know, this is why those worlds have become so exciting, because water is being vented into space. Water that is enriched by the various chemicals that life needs, that is enriched by hydrogen gas, which life would use as an energy source. All you have to do is take some samples, study it locally, or bring it back home to Earth, and we can get a much better answer. So that's sort of one, which is just this direct observation way. The second method is going to be remote observation. We're going to look at the chemistry in the atmospheres of exoplanets and hope to see the kinds of gases in that atmosphere that tells us that there's life there. And that can be done here in the Earth. You know, you can sample the atmosphere of the Earth. You can measure the presence of oxygen and ozone and methane and water vapor and carbon dioxide and sulfur dioxide and then other hints of other kinds of molecules that are really only produced by life. The problem is that those amounts are very low. And so to make an observation is really tricky. When you think about the observations that were made from Venus, right? They detect the presence of phosphine in the atmosphere of Venus. That's a gas that's produced by life here on Earth. And yet it is inconclusive. Scientists are arguing about whether or not phosphine was actually detected. And even if phosphine was detected, whether it can only be produced by life. We know that there are non-biological ways that life can produce things like phosphine. So this will always be inconclusive until we have boots on the ground, labs on the site, people are doing a lot of work to try and get to the bottom of whether or not this is actually life. Like, yeah, if we saw some kind of Mars rodent scamper past the Perseverance rover, if we saw a tree on the surface of Mars, it would be answered, but we don't see that. And so the amount of, what we're going to be able to detect is going to get harder and harder. And then on the other side, of course, some kind of techno signature, some kind of intelligent signal coming from a civilization that has put chlorofluorocarbons into their atmosphere. They recently had a nuclear war, and you're detecting the radiation left over from their war. These are the kinds of things that might be a lot more detectable and give you that certainty. So prepare yourself for decades, if not centuries, of uncertainty. That is what the future holds for the search for life in the universe, which isn't great because, we want an answer to this question, but it is the most profound question that humanity has probably ever asked. And so, when we do get the answer, it's going to be sweet. Sweet, sugar, lipid, but all back around. Too bloody quiet again. Why did everyone turn up your volume? It's just me. It's like I'm not having a conversation with other people. My volume is set because this is the volume setting that is good for the audio editor. And so, like, when I'm looking at my recording device, I'm seeing it go. Now I can crank the audio in because they did a reset. No, I'm looking at my microphone audio, and it is sort of not quite peak. It's perfect. So if I increase the volume, then it would change. You would start getting it would peak, and you'd lose data at the top end. So turn up your volume. I apologize if my audio is a little quieter than other people. Okay. Where are we at? Orion Spur. Shouldn't we pray there's no life on the moons of Saturn? We're going to need those resources to survive long term in this solar system. I think that's an interesting question. This sort of comes down to what are the ethical issues of us using the material in the solar system matched against what is interesting scientifically for us to find in the solar system. And so there are these places in the solar system where there might be life, right? Under the ground on Mars, under the surface in Europa, Enceladus, other icy moons in the solar system, and that, our future space exploration plans are going to require water, and lots of it. Water is fuel that you can split the water, use the hydrogen, use the oxygen. Like, there's going to be all these reasons why you're going to need access to those resources, and that, human life, we're going to be bringing our life with us. That is going to infect the surface of these planets. That, if we do at scale start to mine the surface of Europa for its water, who knows? We'll probably never get to this place where we've, destroyed Europa entirely for our, for our swimming pools on Ganymede. I don't know. But who knows, right? Like exponential growth takes you into funny places. And I think that we live in this moment right now where we don't know the state of life in the solar system. There are two possibilities. One is there is no life, that the only place where there's life in the solar system is Earth. And so the rest of the solar system is just raw material, right? Like even here on Earth, right? If you drink a glass of water, you are drinking life. And you're like, oh, should you be concerned about the life forms that you're drinking? No, because the water's going to make more, right? Like, don't worry, there's plenty of life filling all the water that we drink, and there will be more when you drink it. But on a place like Europa or Enceladus, as soon as we arrive, we're going to be covered in our filthy bacteria, and we're going to potentially infect those planets and replace the life forms with Earth life, obscuring the answer to that question. And so do we have an ethical question on whether or not we should do that or not. And then you have the sort of that deeper question, which is just like, if there is no life there, then that stuff is just raw material, right? Should you feel sad about destroying Europa? Well, yeah, because it is beautiful. And there's like these sort of ethical reasons, aesthetic reasons why you wouldn't want to tear apart Europa. And also it's a gravity well, and gravity wells are for suckers. So instead of tearing apart Europa, tear apart a comet, tear apart an asteroid. Those things have no gravity well pretty much, and still have tons of resources that we can use. Maybe down the road, when we've torn apart all of the comets, all of the asteroids, we're starting to look over at Europa and Enceladus and go, should we start working on those now? But that will be an extremely advanced society, something that is sort of not understandable from our sort of current civilization, and we'll let that figure it out. But I think, there is a really good argument that there are places in the solar system that are worth preserving purely for their just existence as a wilderness and their potential for life. Mars is one, Venus is another, the large icy moons of Jupiter and Saturn are others. There are places that should be considered wildernesses in the way that we have places that are considered wildernesses here: mountains, forests, oceans, archipelagos, really interesting places. And that there's so much raw material out there in the solar system. Why do we need to tear up Mars, when we could just kind of leave it for a while and enjoy Valles Marineris and enjoy Olympus Mons and enjoy all of the weird terrain and the ice caps on Mars? Because again, it's a gravity well. You're gonna have to go down there. You're gonna have to pay a huge expense to go down to the gravity well and come back out. So we'll find out. But if I sort of know human tendency, we're just gonna use it all up, whether there's life in it or not. Just assume that's what's gonna happen. NK on videos, is this live? Yes, this is live. Rhythm Chuckler, I've noticed it's not just the stream. Most streamers on YouTube are having low volume too. I'm comparing to the ad volume. Are there ads? There should not be ads. Did YouTube turn ads on? No. Tell me if you're seeing ads. Ooh, that would make me so mad. Okay. Alan Gross is saying they're not seeing ads. Good. Because that I would be pissed off if there were ads. Hey, Zephen's here. Beep boop. The robots have been handling things great. Well, yeah, AI. Juju to full. Since brown dwarfs emit their own glow, is it possible for a habitable zone to occur around them? Yeah, absolutely. Brown dwarfs are considered failed stars because they are not running fusion, like pure hydrogen fusion in their cores. They are too small, too low mass. They do have a form of fusion. They can have deuterium fusion, but it is sort of less energy. They're putting out less heat. You can only really see them in the infrared, but they are putting out heat. And wherever you get heat, that gives you a habitable zone. And so, it's assumed that there are going to be moons, planets, around brown dwarfs. Have any been detected so far? I feel like we reported on a planet around, maybe not. Okay. It's assumed that there are going to be planets around brown dwarfs. They're big, they're massive, they formed. Some of them are going to have planets. And what is probably another contribution of heat is the kind of tidal interactions that we see around a place like Jupiter, that you've got multiple moons, the moons interact with each other and with Jupiter, and that creates this internal tidal flexing in the moons. You know, Io is the most volcanic place in the solar system. Europa probably has liquid water under a thick surface of ice. And so you get this heating. And so you're probably going to get this sort of 1-2 punch. You're going to get the heat coming from the brown dwarf, and you're going to get the tidal interactions between all of the planets that are orbiting around the brown dwarf. And that's going to put things into the habitable zone. But like, I think it's, you know, you could get liquid water on the surface of those worlds if the conditions are right, but you're not going to get like light coming into that world. So it'll be completely dark. It'll be liquid, but it'll be completely dark. And so you're really limited to the amount of available energy. You're not getting the 1,000 watts per square meter that we experience here on Earth. You're going to get whatever are the chemical interactions that are coming from volcanic activity on that planet. But it's not zero, and so it could theoretically support life. And, you know, we see life that is completely independent from the surface of planet Earth down at the bottom of the oceans. You've got these vents, you've got sulfuric gases that are coming out, and it is supporting an ecosystem in the darkness without sunlight. So if it can work here on Earth, it could probably work on planets around a brown dwarf. Ed Skeptic 2IE. YouTube will even spoil your sleepy science video with their disgusting loud ad interruptions. Has anybody found a sleepy science video that isn't just AI? Should I make sleepy science videos that are not AI? I was thinking about that. I'm like, okay, like clearly this is a thing that people want, although I don't understand. Like maybe my videos are already sleepy science videos, right? Or do I just speak in a monotone? Do I just change the way I prepare this information? I don't know. But it would be nice if they were like scientifically accurate. Like this, is this how science on YouTube dies? Is that AI is able to generate hours and hours and hours of people talking about scientifically sounding AI slop nonsense put to pictures, and the whole thing is just generated by an AI. And because that stuff is so easy to produce, people like it, and then they think it's real. I don't trust anything that's not in a sleepy science AI video, as opposed to some coffee-infused Canadian who is speaking a little too quickly early on in the morning. You know, I don't want that. I want sleepy time science. People listen to John Michael Godey. Goes, people listen to me to go to sleep with as well. I know many people have said that they find my intonation, my tone, I don't know, helps put them to sleep. And I use other YouTubers to go to sleep. And I'm not looking for a sort of monotone, sleepy style. I'm looking for something that ties up the verbal part of my brain so that I no longer am thinking thoughts and I just start sleeping. So it's interesting. Compilation video. Yeah, it's probably the way. A big compilation video. I've pitched that to Anton, not that Anton, my producer Anton, about us doing a compilation video. And he's kind of been against it, that recycling too much content will cause issues with the YouTube algorithm. But now he's listening to me because he chops up this episode for the various overtime segments that we do on, you know, now and into the future. So he's going to have to just like confront this idea as related to a conversation that I'm having with the audience. So Anton, you hear that? Is this a vote for that idea? Do we do compilation videos? Like, there are some video game streamers that I watch where they do like lots of little parts to their video. I think of like Ambiguous Amphibian, who does great series for Project Zomboid and things like that. And the series can run 10 hours. And recently he's been combining them into compilations where it's just the whole thing all in one big long video. And there's a lot of views to it. So it feels to me like there's value there for us to make a compilation on some topic. And then that turns into sleepy time video, right? Like, we could just do the Fermi paradox and just take every single question that we've ever done related to the Fermi paradox, jam them into one big long video. It's going to be 8 hours long, and it's just going to be talking about the Fermi paradox over and over and over again, and all the different flavors, all the different questions, and so on. Is that the way? Anton, But then we're using content. Is it a different channel? I don't know. Sean Man, Fraser, what universe would you rather be in? The Star Wars universe or the Star Trek universe? Obviously the Star Trek universe, right? The Star Wars universe is like brutal and cruel and unfeeling, with people always at war, people always gaming for power, with an empire that is exhibiting its brutal authority over a populace, where even people trying to do right are crushed under the thumb of an autocratic empire. No, thank you. Star Trek, where you've got a grand federation of planets that's trying to do what's best, that they're interacting with a larger universe with curiosity and good intention, where you're in a post-scarcity society where people get to decide what they want to do with their lives because of whatever they find intrinsically exciting. There are threats, there are challenges, but there are bold sort of aspirations that the society holds itself to. I will take Star Trek every day over Star Wars. Yuck. Ugh, I don't want to live in Star Wars. It sounds like a nightmare. It is dystopia. It is not a good universe. It is a bad universe. You don't want your own personal lightsaber? No. Like, a personal lightsaber is a sword. Like, yeah, maybe it's a sword that lets you cut other things that a sword can't let you cut, right? But a laser cutter will let you cut those things. A CNC machine, right? I can't think of a lot of times where a lightsaber would have been handy. The only thing that's like a little bit different, it's not even a little bit different actually, is like people have their own spaceships. While, spaceships are more expensive, and so they're generally crewed by people in the Federation. But no, people have their own spaceships in Star Trek as well. Picard gets his hands on his own spaceship. Yeah, so no. Adam Redwine. What's the next target for the group that imaged the two black holes? So more images of those same black holes. The problem is that the Event Horizon Telescope, which imaged both the black hole at the heart of M87 as well as the supermassive black hole at the middle of the Milky Way, those are the largest black holes that are available to be imaged. And in fact, they're kind of roughly the same size in the sky. Even though they are dramatically different distances, it's that the one in M87 is gigantic, while the one in, I think, 400 million? I forget the exact size. Anyway, the one in M87 is gigantic, while the one in the Milky Way is smaller. It's just that visually on the sky, they are about the same size. And that there are no other black holes that are kind of within striking distance of the Event Horizon Telescope to make the same kind of image. Now, there are other observations, and there was actually a paper that we reported on just a couple of months ago, that they're looking at the larger environments around other black holes, looking at the magnetic fields and the way they interact with their environments, but you're not seeing that shadow of the Event Horizon in the way that you did with M87 and Sag A-star. So what do you do? Well, the problem is that we're out of Earth, right? Like the Event Horizon Telescope is already the size of planet Earth. And so we can't put more telescopes to make that interferometer, the baseline, any larger. To make it a better telescope, we have to go to space. We've got to add telescopes to the Event Horizon Telescope that are now on the moon or at one of the Lagrange points. And so then you're getting a baseline that is hundreds of thousands of kilometers, potentially millions of kilometers across. That gives you the new resolution, allows you to look at other black holes. And, I've reported on this quite a bit and interviewed people. There was a radio telescope or like a radio instrument that was orbiting a geostationary satellite or like at one of the L Lagrange points. And so it was able to provide a bigger baseline. They were able to make sort of proof of concept that you can combine the observations from ground-based telescopes with a space-based telescope, and you can have that interferometer experience. But right now there are no solid plans. There was another paper that I reported on, sort of talking about what targets you get, and you get dozens, right? Dozens, if not hundreds of supermassive black holes suddenly become observable, that the observations that you get to make of Sag A star and M87 star go up. You get closer to the event horizon. So there's a ton of really important, really useful reasons why you would start to extend the event horizon telescope out into space. And the cool thing about radio telescopes, right? Like the event horizon telescope is not a telescope. It is a party, right? Where a bunch of different telescopes all together agree to make similar observations on the same object for a certain duration of time. And then when they're done, they gather up all their data, they send it to a central place for processing, and then the telescopes turn and they do their normal jobs. They look at other stuff. And so the same thing, you could launch a radio telescope into space, and it could make observations as part of the Event Horizon Telescope, send all those data back home. They could be crunched together in one place. And then that telescope would then go on its work as a radio telescope in space. The problem with radio telescopes is they work really well on the surface of the Earth, that there are these gaps in the atmosphere, like not physical gaps, but sort of like wavelength gaps that various kinds of radiation are able to pass through. One of those obviously is visible light, right? We can see stars, we can see the sun, we can see out into space because visible light can pass through the atmosphere of the Earth. It is obscured by clouds. They do not pass through clouds, but it does get through the atmosphere. Radio waves go through clouds. And so you can have a radio telescope during the day doing its work, looking through clouds to some extent, and be able to make observations. So there's a lot of reasons why you just build your radio telescopes on Earth. So you're going to need something like this. Like, let's extend the Event Horizon Telescope. Let's build a custom-built, really cool radio telescope out in space. There are other advantages as well, but it just hasn't been a gigantic, huge priority. But we're getting to this place where, you know, the astronomers are continuing to map out the magnetic fields around M87, the polarization of the light coming from M87, you know, trying to get a sense, maybe a hint of the photon ring, or like it's just continued observations of these targets because that's all that's large in the sky. There you go, Beach Schnauzer, a compilation of your most listenable interviews, please. That's a good idea. Outcast P, have you read Kim Stanley Robinson trilogy on Mars terraforming? What are your thoughts on the books? Books are good. They're science fiction books. Are the thoughts on terraforming realistic? Probably not. But they're cool science fiction books. Like, what would happen if humanity really wanted to live on Mars? They're great. Great books. House of Wisdom and Peace. Does NASA have any plans after Artemis, or do you think they will rely solely on private companies to establish a permanent presence on the moon? Like right now, it is so tough to give any definitive answer to this question because everything is in flux. Everything is in limbo. You know, a lot of the, like, let's talk about all the pieces. And of course, you know, we're talking about this at the end of 2025. The Space Launch System exists, has been proven to work, and has launched one uncrewed mission around the moon. The Artemis 2 mission is going to be using a Space Launch System with an Orion capsule, and it's going to have 4 astronauts, and they're going to do a mission around the moon, and they're going to come back to Earth. It's going to be essentially Apollo 8 all over again, but with new gear, right? Artemis 3 depends on Starship. that this giant, fully reusable two-stage rocket is going to work. It can fly to space, it can refuel, it can go to the moon, it can land on the moon, it can bring astronauts, it can meet up with the astronauts in orbit, go down the surface of the moon, bring them back up, put them back on their capsule and bring them back home, and then they can come back to home to Earth in their Orion capsule. Spaceship has not been demonstrated to perform its full requirement, and the original time frame, what's like 2026, 2024, 2026, 2027, who knows? But it is almost certainly going to slip. Artemis 4 was going to be beginning the construction of the Deep Space Gateway, and over the course of several of those missions. Around the Artemis 5 or 6 range, then you'd be getting probably delivery to the surface of the moon by a Blue Origin's lander, and then you would sort of mix things up, and you would continue on, and you would establish a more permanent presence on the surface of the moon. You would eventually move towards building a lunar base. At the same time that the Chinese are doing their version of this, that they're going to probably have first boots on the moon 2030. They're going to build out more and more stuff on the surface of the moon. They're testing out, turning lunar regolith into objects. So where we stand right now is just in this mess. The SLS is incredibly expensive, probably too expensive and not sustainable. And a lot of people are trying to cancel it for other cheaper options. But there's a lot of established political will to keep this spacecraft going. It's already been built. Various components have already been constructed for all the different SLSs down into the future. Starship has not been on schedule. It has not delivered the fully reusable rocket in the way that everyone was expecting. And there's still a lot of steps to go before it fulfills that part. The Lunar Gateway has been canceled in all extents. Who knows if it'll be resurrected, but right now it's probably no longer a thing, even though most of it has already been constructed. And that doesn't give you that, the whole purpose of the Gateway was to give you this halfway point to the moon, gravitationally speaking. Now, obviously, there are people who deeply disagree with this opinion. Robert Zubrin thinks it's a waste. No problem. You can make arguments either way. And so there is no coherent, cohesive plan. And earlier on in this video, one does not simply arrive at the moon. You can't just accident your way to the moon. You've got to plan very carefully, commit enormous resources, have an unwavering vision throughout the entire process. And we just don't have that. So I think Artemis 2 will happen. It's going to happen next year. Seems like all the pieces are in place. It's just going to happen. What happens after that is question mark, question mark, question mark. Now, at the time that I'm recording, Jared Isaacman is sort of getting spooled up and ready to become the new NASA administrator. He has ideas. He has plans. He has reiterated the sort of current White House administration to their vision of sending people to the moon, starting to understand how to do harvesting resources from the surface of the moon to support some kind of long-term presence on the surface of the moon. But come on, right? This is new plan, new goal. Things change. You have to recalibrate. You have to figure out what you have to work with, what budgets people are willing to give you, what compromises people are going to be able to make politically. You have to consider the will of the contractors, the subcontractors who've put in all this energy in this effort, all of the workers who are across the United States who are working on specific kinds of projects and programs who are going to get potentially laid off if you shift gears. Again, if you cancel SLS completely, you are going to have tens of thousands, if not hundreds of thousands of aerospace workers looking for a job. Will SpaceX be able to pick them all up? There's no path forward that doesn't cause disruption at a massive scale, politically, financially, everything. So it is currently limbo and a mess, and I have no idea how people are going to untangle this in a way that is smooth and streamlined and has a long-term persistent vision that's going to last for multiple administrations, multiple administrators, and achieve some kind of long-term vision. Matthew Bronson, I'm now hooked on Plurabus because of your mention a few weeks ago. Do you think the idea of transmitting DNA data to create artificial life is a viable way to colonize the galaxy? So Plurabus is a show on Apple TV, and I'm going to spoil the sort of the concept of it because it's so compelling, and it's like laid out in the first half hour of the show. And that is that astronomers receive this signal that's coming from another planet. I think it ends up being Kepler 28. Anyway, and they decode the signal, and they realize that it's probably some kind of DNA sequence. They synthesize it in the lab, and they infect a mouse with it, and the mouse infects a person, and the person becomes part of a hive mind. And then over the course of the next few weeks, they infect everybody on Earth. And the main character is immune, and there's a few other people that are immune, and they're having to interact with this hive mind that has now control of planet Earth. And it's a fascinating concept. Obviously, the hive mind idea has been tackled many times before. We've got the Borg, we've got Rick and Morty has done it, Futurama has done it, and then science fiction has done it plenty. But to actually sort of see it told with this level of grace and storytelling is wonderful. And so the central, and then, like the central conceit about this is that essentially an alien civilization conquered planet Earth by sending them a bad idea. And that is like just the best idea. And this, this isn't new to Plurabus. This idea has been thought about. It's called an infohazard, which is that you can give somebody a piece of information that is hazardous just to know the information, right? If you know that there is a button somewhere that you can press it and it will destroy the Earth, right now, you're no longer just this person that's living blissfully on planet Earth. You are deciding whether or not planet Earth exists or not by default, or whether or not you press that button. And if you tell anybody that that button exists, now suddenly you have no more control over that button, and maybe someone else is going to press that button. That's going to destroy planet Earth. So that's an info hazard. And then when you think about the ways that you could invade and colonize another star system, right? You send the ships. You get down there and have ground combat. They resist. It's very difficult, very complicated, very expensive. You send a ship that's only job is to destroy the planet. Again, very expensive. You send a black hole designed to destroy the planet. Very expensive. You send a bad idea. Very cheap. Here's a piece of computer code. Run it on your computers. Who knows what might happen? Right? It's going to help you. Someone is going to take the risk and run that computer code, and then the results are going to follow. So I actually think, when I sort of think about all of the ways that a malevolent civilization would want to deal with potential future threats, try to have people join their empire, that idea is really elegant, and it's a thing that we should absolutely be watching out for, right? If we receive a message from another civilization, should we even look at it? Should we even read it? Should we even attempt to decode it? That is a serious question about risk. And yet, inevitably, right, if this information is just there being broadcast in the sky, anyone with a radio telescope points it at that signal, receives the information, they're going to want to know whether or not they can respond to it. This was tackled in the three-body problem, that one radio astronomer happened to be detecting this signal from an intelligent civilization. She responds. They warn her. The operator on the other side says, like, don't talk to us. Don't respond. Like, we will do bad things to your civilization. And she does it anyway. And they do bad things to her civilization. And she regrets it. And so, yeah, sending another civilization, the bad idea. And so what I love about this is that the thing that we want the most is to know whether or not we're alone in the universe, right? Like, this is the most profound question that humanity's asked. And yet, if the answer to that question is provided to us on a silver platter, the best thing for us to do is to throw that silver platter in the garbage, right? That we receive a signal, an intelligent civilization that says, welcome to the Galactic Federation. Here is your guidebook on how to become, how to join us in this beautiful future of peace and prosperity and high technology. Just read the book. Just read the manual. That's all you need to do. We should take the manual and we should throw it in the garbage because that is what's safe. Otherwise, we potentially risk losing everything. And that, we think we can look at the message and go, oh, I see what they're doing here, right? It looks like it's a computer program that gives us the cure for cancer, but actually it's a computer program that gives cancer. But a highly intelligent, advanced civilization will be so advanced that we won't catch the flaw, the bug, the code, the bad idea. We will just run it and we will suffer the consequences. So yeah, like if we actually literally, if you think about, say, contact, right? And they receive this signal, and then based on the signal, they decode it, and then they build the machine. The machine allows them to wormhole travel. No, don't do that. Take that idea, thank them for sending it, throw it in the trash, and then come up with a new way of communicating that is safer. But great show. I would say Plurabus and Alien Earth are the two best sci-fi shows of the year. And both of those have gone on to my top 10 sci-fi shows. So it's a very good year for science fiction. When you think about, historically, my favorite television shows of all time, and two of them were made in 2025. That's a very good year. And one of them isn't even done. Right? We still got one more episode of Plurabus. But I am so excited about that show. Okay. Well, it's Marcus. Would Fraser join the hive mind voluntarily? I wouldn't. No, I would be like Carol in the show. I would absolutely not join the hive mind. And it's funny, my wife and I were talking about it. And I'm like, she's like, would you join the hive mind? I'm like, absolutely not. She's like, I would. Like, it's crazy. That's, I think for most people, you'd be one side or the other of that, right? You would join the hive mind or you wouldn't. And I wonder what that tells us, like, because my answer is just like, nope, absolutely not. I prefer my individuality. But it's an interesting question. All right. We've reached the end of the show. Here we are, 2-hour mark. Now, I know we started a little late, so you get one extra minute. I apologize if you've been shorted content, but we'll make it up to you next week. Or never. Anyway, thanks in advance to Anton and Chad who have to deal with this nonsense. Thanks to the moderator. Thanks to Zapfan, and I think Raj Lucer's there. So thanks, guys, for helping to monitor and manage things. What's coming up? Great interview that I did last week. Hopefully that's going to show up this week. We've got another interview that we've also been sitting on for a long time that's got kind of a hilarious backstory, but we will sort of reveal that as we release the interview. I'm going to put up the call for the patrons question show today. So those of you who are patrons, get ready for that and give me your questions. And apart from that, I'm going to record Astronomy Cast with Dr. Van Vliet live in an hour from now. So at 11 o'clock Pacific time. We will see all of you next week. The progress marches on. We take no breaks for Christmas and or the New Year. All right. We'll see you next week.